So in this video here, we're going to be talking about graphing systems of linear inequalities. Now, we've graphed linear inequalities before. You might remember us drawing a line and then shading above or below. Now, for linear systems of equations, basically it means you have multiple equations you'll have to graph. In this case, we'll be graphing usually up to two linear inequalities at the same time or on the same graph. So let's just start with a warm-up here first. And this warm-up is one of those word problems where you have to change them into a system in order to solve. So this one says, last week at Animal RS, sold 25 total pets. That might be important, so I'm going to underline that. So we sold 25 total pets. Some were cats, some were dogs. And they made, so the total, $1,125. The dogs sold or sell at $75 and the cats sell at $25. They want to know how many dogs did Animal RS sell. So first off, when we're creating an equation to represent this system to solve for how many dogs, we need to declare some variables. So that's where I like to use just x and y as my variables. So I'll declare what x is going to be and what y is going to be. So in this case, I want to know how many dogs are being sold at Animal RS. So I'll make x number of dogs. And y could be the number of cats. Now, I don't need to figure out the number of cats are sold, but it might be nice to have that as a variable to help me solve for the number of dogs. Since when you're creating a system, you usually need two variables and two equations. So let's go ahead and make those two equations here. So my first equation could be, representing the total amounts made. So I noticed that I sold $1,125 worth of pets. So that tells me this is the total. So when I add two things, I should get this amount. And so when I think about how I want to construct it using x's and y's, well, I know the price of a dog and I know the price of a cat. So if I took the number of dogs multiplied by the price of dogs, so 75 times x, and the price of cat multiplied by the number of cats, then I can make an equation where it says when I add the two total amount of dogs and the total amount of cats, how much I made from both sets, I can get the total amount of money I made for that sale. And so in this case, I've written one equation. My second equation, what I know is that there were 25 pets sold. So if I were to add the number of dogs and the number of cats sold, I should get 25. And there are my two equations. Essentially, one of the equation represents how much money I made, and the other represents the quantity, the total quantity. So from here, I can go ahead and try to solve using elimination, since this is in standard form. So if I were to look at the variables, maybe I'll try to cancel out the y's just because the y has a smaller number. Now there's no opposite signs here, so I'm going to multiply by negative 25 to try to make the y's cancel. Oops, meant to wrap that around. And so if I multiply negative 25, this would make it opposite signs but same coefficients. So the y's would cancel, but I need to multiply that to all the other terms as well. So when I take the first equation, I'm just going to bring it down as it is. I'm not multiplying anything to the first equation. Whereas the second equation, I'm multiplying in a negative 25. So that would be negative 25x, negative 25y. And 25 times 25 is negative 625. And so if I were to combine them, then it looks like my y's cancel out as predicted since they're opposite signs and the same coefficient. 75 minus 25 is 50x, positive 50x. Bring down the equal sign, and 1,125 minus 625 is going to be, 500? Yeah. So now if I were to divide by 50 to try to get x by itself, my x here is equal to 500 divided by 50, which is 10. Okay, let's take a moment to understand what does 10 represent. So x represents number of dogs. That means there were 10 dogs sold at the pet store. So they only wanted the amount of dogs that were sold, and we found it. So I'm going to write here 10 dogs. So 10 dogs were sold. They didn't ask how many cats were sold, so I don't need to give them that information, but I could give them that information. All I have to do is plug in my x value into one of the equations and then solve for y. So I could do it, but I don't need to. So moving on into graphing systems of equation, because that's the new stuff that we're going to be talking about. When it comes to graphing linear system of equation, it's pretty much the same as last time. You want to start with solving for y and getting that y by itself. Why do we want to do this? Because we need to have the slope and the y-intercept to graph. So when you try to get y by itself, you can identify what is the slope and what is the y-intercept, so you can make your line equation. As for graphing the equation, you're going to need to account for when to use a solid line, which is when you have an inequality with a line underneath or an equal sign. And a dashed line is when there is not a line or an equal. Shading, we always shade above the line when y is greater than the equation. When y is less than the equation, you want to shade below because that's where all the y values are negative. And I'll go over why this is the case once we start actually graphing. And a couple of things that I want to make us notice is the fourth part is we're going to need to find the intersection where all the colors meet. And so this sounds kind of weird, but in graphing systems of linear equalities, I highly recommend that you grab your color pencils or your markers, basically have multiple colors. If you have to use a pencil and then the others are using a pen, feel free to do that. But I highly recommend that you bring out your colors when you're doing this. So have maybe 3 colors, and you'll see why once I start to work some of these problems out. It makes it easier to read your mathematical work. All right, here we go. So first, let's review a little bit about graphing lines. In the first example here, I made it really simple. Notice how x and y is already by itself, so there's no solving that needs to be done here. We can go straight into step 2, which is graphing. And so if I were to do that, let's just first think about how I would graph an equation that's just y and a number. Whenever you have an equation that's just y and a number, that is when you have a horizontal equation. So anytime it's just y and a number, this is a horizontal line. Whereas when it's just x equals some number and nothing else, this is a vertical line. And let me show you why that's the case. So if I were to graph y is greater than 5, the only thing I have here is the 5. And I know it has to be something that is on the y-axis because this here is a y. So I would go to, let me see if I can grab some colors here. Maybe make this green and then make this pink. So I'll call this equation 1 and this one equation 2. So for equation 1, I have y is greater than 5, so I'm going to plot my y-intercept at 5 because this says this value 5 is on the y-axis, so here it is. And if I were to draw this line, there's no slope here, right? This is just the y-intercept. So that means I'm going to be drawing a line that cuts through the y-axis. And if you look at this inequality here, this needs a dashed line because there's no equal sign. So I'm going to make a horizontal line that cuts through just when x is y equals 5. So here's y equals 5. Now this inequality says that y is greater than 5. So if y is greater than 5, or in this situation, you want to shade above. Well, and it's because all the numbers that are bigger than 5 for y are up here. So we're going to shade above our horizontal line. And there we go. Now we're going to do it for x is less than 7. So let's go to the x-axis this time since this is x. And we need to plot it at 7. So let me grab my pink pen. So here's where x is equal to 7. And we need to, since this is x, it needs to cut through the x-axis. So in this case, we're going to be drawing a vertical line, and it needs to be a solid vertical line because the inequality has an equal sign underneath or a line underneath. So drawing a vertical line like this, I'm now going to do my shading. So grabbing my highlighter here, this x says it's less than or equal to 7. So numbers that are less than or equal to 7 is going to be shading this direction. Those are numbers smaller than 7. So let me do my best to try to color. So you can see why I'm coloring here, so that way you guys can see where do the colors intercept. Well, they intercept right here in this part of the coordinate system. So I'm going to box in my intersection to show where they intersect. And they intersect right about here. And so this here is my intersection. And there we go. All right, let's try another one here. So for part B, we have y is greater than -1, and this is an equation where y is by itself. So this is a y-intercept. So we're going to be drawing a horizontal line. So I'm going to go to the y-axis at -1. And let's make this my green equation or my first equation. This one's my second equation. There we go. That way we can do some number labeling here. So this is at -1, and I need to draw a solid line because this has an equal sign. So the first equation is nice because the y is already by itself, so I don't have to do any solving. And then from here, I need to do my shading. So this y is greater than -1, so I want to shade above it because numbers that are greater than -1 are above this horizontal line. These are all the y values that are bigger than -1. So I'm shading where the numbers are supposed to represent. Now this part here, I can see that y is right here, so I do need to get y by itself. So we will need to solve. So I'm going to start with maybe removing the 5x by subtraction. So that would cancel. 3y would come down. -9 minus 5x would come down because they are not like terms, so you just bring them down as they are. And then we need to, looks like, divide by +3. So because I'm dividing by a +3, I don't need to switch my sign, so that's kind of nice. Y comes down, inequality comes down. -9 divided by 3 is -3. And -5 divided by 3 is -5/3x. And I'm writing this as a fraction in front of x so I can see that it's my slope. So it looks like I have a y-intercept at -3. So that would be right here. And my slope is -5, so that's down 5. So 1, 2, 3, 4, 5. And then over 3, 1, 2, 3. So I'm going to connect the dots with a solid line because this here has an equal sign for the inequality. So I need a solid line. And now I'm going to go up 5 and over 3 just so I can extend this. All right, so I'm just going to extend the graph. Oops, let me draw that a little bit better. Okay, so looking at this graph, I do need to shade, and it says y is greater than this equation. So if y is bigger, that means I need to shade above this line where the y values are pointing towards the positive direction. So that would be this side here. So this would be shading above the line because all the y values on this side are more positive. Whereas if I were to shade down here, notice that it's pointing towards the negative y value, which is not what I want because it says y is bigger. So where it intersects, where the green and the pink intersects is right about here, or where the two colors intersect. By the way, if you can't see green and pink, because I do have students that are colorblind, feel free to use a different color, one that you can see. I have some people who will not color, they'll use textures instead. So they'll like do like different types of shading to help them see. That way they can see where the intersection would meet. In the next video, I will show you guys how C and D is done. So check out that video if you want to see the rest of this journal.